Alexander Baina here, and welcome to another episode. This will be about factors affecting the Earth's climate. The first factor that can affect the Earth's climate is volcanic eruption. During a volcanic eruption, a volcano can spew a large amount of gas, aerosols, and ash into the atmosphere, specifically in the stratosphere. The sulfur component of the gas, in the form of sulfur dioxide, combines with water will form sulfuric acid aerosols that reflect incoming solar radiation. This event can significantly cause global cooling. On the contrary, the volcanic carbon dioxide, which is a greenhouse gas, can promote global warming. Another factor is continental drift. The circulating heat of the Earth's interior causes the continents to move, which is responsible to their configuration, such as shapes, sizes, location of ice caps, and global positions. These are all factors that affect the atmospheric circulation processes. In other words, our present configuration of our continents today has a great significant effect to the climate that we have now. Any object on Earth has the capacity to reflect solar radiation. There is a ratio of the incoming radiation to the reflected radiation between the Earth's surface and the atmosphere, and this ratio is called surface albedo. We have two examples about the concept of albedo. The first example is, as the ice expands, more solar radiation is reflected to space and less is absorbed by the surface, causing the temperature to decrease. The second example is, those high clouds can trap more emitted energy from Earth but reflect less radiation or solar radiation, and the consequence is a higher temperature is accumulated. Another factor is mountain building. Wind and precipitation patterns are altered by the presence of mountains. Mountain ranges block rain or precipitation on one side of the mountain, and this is known as the leeward side. This is causing an area of significantly reduced rainfall, and deserts are created. This phenomenon is also called rain shadow effect. There are several rain shadow effect areas in the world. Therefore, mountain buildings alter climates and ecosystems on either side of mountain ranges. The land absorbs solar radiation. The ocean as well stores solar radiation, distributing heat and moisture around the globe, since the atmosphere also helps to retain heat. This is how the atmospheric and ocean exchange heats. Occasionally, there is the slight changing rate of solar heating of the Earth and atmosphere. As a consequence, this affects the cloud formation process. Consequently, alters the weather and climate. The amount of heat energy received at any location on the globe is a direct effect of sun's angle. Because heat concentration is dependent on the angle at which the sunlight strikes Earth, and it varies with location and time of the day. An example to this is, the sun is concentrated so much during noontime, while early in the morning and dusk, the sun's rays are minimal because it has a smaller angle. This is also very similar to what is experienced by the people living along the North Pole and the South Pole. The sunlight hitting the area is at a lower angle. Another factor is season, since the Earth orbits around the Sun and is tilted on its axis. This configuration creates different seasons. On a winter season, the Northern Hemisphere experiences longer nights and shorter days. Aside from a low angle and low intensity of the Sun, it will have a shorter sunlight exposure. The opposite happens during summer. However, for us in the Philippines, we are situated near the equator. We cannot usually feel the significance of longer nights and shorter days, or vice versa. And the last factor that affects the weather and climate in our planet is the presence of this stratospheric dust, which includes interstellar particles which reflect sunlight. This is said to be the cause of the global snowball glaciations, also known as the snowball Earth.